Hello, everyone. Welcome to the hypothesis testing and scientific method video. Let's go ahead and get started. Okay. Hypothesis testing and the scientific method. So part of our objectives today, understanding the link between those two things, learn some of the key concepts of hypothesis testing, and explore those within the context of the scientific method, and also discover the role of evidence-based decision-making. All right, so the scientific method, the definition is a systematic approach to acquiring knowledge through observation, experimentation, and inference. And so the key steps to the scientific method are observation, question, hypothesis, experiment, data analysis, conclusion, and communication. All right. Now, hypothesis testing is basically the statistical equivalent to the scientific method. It plugs in certain parts of all those steps. All right, so a hypothesis is a testable prediction or explanation for a natural phenomenon. All right, so that's a very crucial step in that scientific method. If we go back, we see hypothesis number 3 on the steps here. All right, so the key components of hypothesis testing are the two hypotheses, the null and the alternative. The null is denoted by an H0, and the alternative is denoted usually by H1, but it can be by HA2 as well. All right. The third component, or key component of hypothesis testing, is the test statistic. And then we have the significance level, or the p-value. All right, so to begin with, the null hypothesis. It's the default hypothesis, often representing no effect or no difference. All right, so an example would be there's no difference in blood serum cholesterol in patients who take experimental drug versus those who took a placebo. All right, now keep in mind that the null hypothesis, we call it null because it usually is one that represents no effect, okay? The alternative hypothesis is the opposite of that. So it contradicts the null hypothesis. So in this, for our example of the cholesterol, the blood serum cholesterol in patients who take an experimental drug is lower than those who took a placebo. Okay, so the null is no effect, the alternative is an effect. All right, so the third key component to all this is the test statistic. All right, it's the numerical value calculated from the sample data. So if you collected data, then you usually calculate something. Okay, and so the examples would be like a t-test or a chi-square test or an f-test if you're doing analysis of variance, things like that. Okay, it's some numeric value that is based upon assumptions made about the population from which you are drawing from. All right, and so the significance level is usually denoted by alpha, and the definition of the significance level is the probability of rejecting a true null hypothesis. All right, we usually set that around 0.05, 1 in 20. And that's really an artifact of the days in which we didn't have computers and all these things had to be done by hand. But typically, journal articles like for their authors to kind of stick by that 0.05 significance level when they're drawing their conclusions. All right, but what you typically see in journal articles are p-values. All right, so a p-value is like a measure of evidence. It helps you determine whether the results you're seeing are likely because of a real effect, like the drug working, or if they could just happen purely by random chance. All right, so another way of thinking about this is that p-value tells you the probability of getting results as extreme or more extreme than what you observed if the null hypothesis were true. So really what you're asking here is how likely is it that we would see these results by random chance? All right, so small p-values suggest that the results you observed are unlikely to be due to chance alone. This often leads to rejecting the null hypothesis and concluding that there is evidence for a real effect. In other words, the drug worked. A large p-value, greater than 0.05 typically, suggests that the results you observed could reasonably happen by random chance. So in this case, you wouldn't have strong evidence to reject the null hypothesis, meaning there is no strong evidence that the drug has an effect. Excuse me. Right, so if we mesh the hypothesis testing paradigm, excuse me, within the scientific method, you'll see that the formulate hypotheses, that be H0 and H1, fits right in there. You have experiment and data collection, calculate the test statistic, determine the critical value, p-value, make a decision, and interpret and communicate the results. So you can see that the hypothesis testing works very well with the scientific method. All right, so let's do an example here where we're testing a new drug. And we were talking about cholesterol earlier. This time we're going to talk about blood pressure. Okay, so we have high blood pressure in a group of patients. And so we formulate the question, can a new drug reduce blood pressure? The hypothesis, H0 and H1. So the H0 would be no effect, and H1 would be drug reduces blood pressure. Okay, so the experiment would be to administer the drug and measure blood pressure. And of course, there's a lot of unpack with that, because you want to make sure that you don't have a placebo effect or anything like that, or it's double blind. So you know, a lot of details there. Okay, so what we would do then is we would calculate a test statistic, and it would probably be a t-test because you would be looking at differences pre-post with this drug, blood pressure, right? And then we would compare the p-value to a preset significance level, something like 0.05, and make a decision to reject or fail to reject the null hypothesis. Keep in mind here that that last bullet point is pretty important, because the way that we do hypothesis testing is really in the form of we have evidence to reject the null hypothesis or we don't. We rarely ever say we accept the null hypothesis. Okay, so we do accept the alternative. When we reject the null, we accept the alternative in its place, but we rarely ever say accept the null hypothesis. Mostly because a lot of people believe that no null hypothesis is true, They're just not true, not false enough to be considered false. Okay, um, so this particular case, we would say we have evidence or we don't have evidence to reject a null hypothesis. All right, so then we have the interpretation and conclusion. And so we would interpret the results in the context of the experiment and communicate findings to the scientific community. All right, so again, the results in the context of the experiment. That you always want to do that. You always want to present the results of a hypothesis test in a way that will be understandable to those who are reading about your research. Right? And in the communicate findings to the scientific community, this could be through presentations, publications, whatever. All right, and so this is obviously an important part of evidence-based decision making. Right? So I think the important part of it is that it is a second bullet point, is it provides a structured approach to verify or reject hypotheses. All right, so when one group does an experiment, everyone that reads that experiment should be on the same page because this is structured. Okay, and so we're not allowing people to draw conclusions without evidence. And so hypothesis testing is a very important part of science. Right? So in our next video, we will look at diagnostic tests and odds ratio and relative risk. So this is some more advanced biostatistic topics, but they're very, very important for medical students because the boards really like to throw some of these questions at you. So we will be looking at those in our next video. Okay, everyone have a good day. See you in the next video.